my lovely students. Good morning and welcome to digital classes. Welcome to the world of chemistry. This is your chemistry period, and as we are doing our unit 4 chemical bonding and molecular structure. So today we are going to start our topic Vseprt theory and geometry of molecule. Already this valence shell electron pair repulsion theory yesterday we have started. The main application of this theory, as we studied that, in this theory we are going to study about the prediction of geometry. Mean, with the help of formula, how we can predict what will be the geometry of the molecule. Okay, so let's start valence shell electron pair repulsion theory. So dear students, before going to start this valence shell electron pair repulsion theory, let me remind you whatever we did in this chapter. The chapter name is chemical bonding and molecular structure. So chemical bonding is what? It is the attractive force between two elements, and after combining those two atoms, it is forming a molecule. Okay, and the question was there, why these molecules, why these atoms are combined, why there is need to combine the atom. As you know that, dear students, except noble gases, all other elements, they are unstable in our surrounding, in our natural environment. Why these are unstable? Because its outermost electron is not stable. In outermost electron there are more than 8 electron or less than 8 electron. The atom can be only become satisfied when it is gaining, it is forming octet in outermost shell. Okay, the stability of a molecule demand that it should have minimum energy. If the electron pairs surrounding the central atom, which is nearer, they will repel each other, thereby increasing the energy of the molecule. So the electron pairs surrounding the central atom repel one another and move so far apart from one another that there are no further repulsive between them. As a result, the molecule has minimum energy and maximum stability. Okay, so already we studied this as last time. We concluded like this way. The valence shell electron pair repulsion theory is what? It is the theory. It is the theory that is used to determine the structure, and with the help of number of bond pair and lone pair. So bond pair is what? It is that pair of electron where electron is sharing the electron to make a bond. Whereas lone pair is what? It is all those pair of electron in an atom which is not going to be involved in forming bond. Okay, so let's start the Vseprt theory. Yeah, I can say valence shell electron pair repulsion theory with help of this slide. It is the shape of a molecule is determined by repulsion between all the electrons present in the valence shell. It is the shape. The molecule shape we can determine by repulsion between all the electrons present in the valence shell. Try to understand each and every line. Electron pairs in the valence shell of the central atom repel each other. It means that electron pair in the valence shell of the central atom repel each other and align themselves to minimize this repulsion. Lone pair of electron takes up more space around the central atom than the bond pair. For example, if I'll take example of water, so we know there are 2 lone pair in oxygen and 2 bond pair in oxygen. Okay, so these 2 lone pair, it will repel as far as then the lone pair bond pair and lone pair bond pair and bond pair is minimum. It means that the repulsion is maximum in lone pair, then lone pair bond pair, then bond pair. Okay, this we have done already. The repulsion is maximum in lone pair, then lone pair bond pair, then bond pair. Okay, so lone pair electron takes up more space around the central atom than the bond pair, and lone pair attract to one nucleus, but bond pair is shared by 2 nucleus. The minimum repulsion is the state minimum energy and maximum stability of the molecule. So there are some postulates of Vseprt theory. Try to understand the postulates and you need to note down these in your notes notebook. First postulate: if all electron pair around the central atom are bond pair, there is no lone pair suppose, then the shape of molecule depend upon the nature of hybridization. Very important. First postulate is very important. If the electron pair around the central atom are bond pair only, there is no lone pair. Mean in that case where formula is without lone pair, suppose BeCl2. So beryllium have how many electron? It is 4. It is 4. So it means that 2 and 2. In outermost there are 2 electrons. So we will make 2 electron. Whereas chlorine have 7 electron. Okay, chlorine have 1, 2, 3, 4, 5, 6, 7 electron. And on the other hand side also chlorine have 7, 1, 2, 3, 4, 5, 6, 7. So you can see these 2 electron are making bond pair. Rest there is lone pair. Okay. Better I will take example of beryllium hydride. Okay, B have 1 electron, hydrogen have 1 electron. So there is 0 lone pair, only 2 bond pair is there. In that case the shape of molecule depend upon the nature of hybridization. What is hybridization? That we are going to study in our next video. So N is equal to number of valence electron in central atom and number of univalent atom, that is charge. Suppose once again I will take BeH2. So that shape or the shape of molecule is totally depending upon this number when there is no lone pair. Hope so you understood. Okay. But when it is lone pair, in case of lone pair, if the electron pair around the central atom is having no bond pair, there is some lone pair. Atoms are not bond pair, but there are some lone pair. Also then the molecule poses distorted shape. In that case the molecule will form distorted shape. I am taking example of again BeH2 and H2O. So you can see this is also a molecule with 2 number. This is also molecule with 2 number. Okay. So it means that by looking these two, it should be maximum time students are thinking there can be same type of structure. I mean if Be is like linear, so H2 is also linear. But no, H2 is not linear. Why? Because of pair of lone pair is there, where there is no lone pair. So when there is no lone pair, the shape will be linear. But where there is lone pair, the shape will change from linear to distorted. Disturbed shape. And because of lone pair repulsion, bond pair repulsion, there are relative order that you know very well. Lone pair is more than lone pair bond pair, then bond pair. Third postulate, it deals with the bond angle of the molecule. Yes, third thing that we need to see bond angle. Okay, and identify the type of hybridization. Hybridization is sp2, sp3, that we will do in our next video. As I said, if number of lone pair increases, then bond pair is also increases. Fourth postulate is if all electron pair around the central atom are bond pair and all surrounded atom are identical, then change of electron activity in central atom as well as in the surrounding atom supposes ideal shape. In case of there is no lone pair, 0 lone pair, but only bond pair is there, then the molecule will pose ideal shape. Okay, so there are steps how we can predict the geometry. Number 1, determine the central atom. You should know the central atom. Okay, like if I will take example of BF3, so we should know what is central. So dear students, listen carefully. I am telling the 5 basic steps to predict the shape, because this type of question definitely is coming related to shape. So you should know the basic. Basic is what? If we will take example of BF3, so out of boron and fluorine, which will be the central atom? This is very important. Yeah, you can take example of CCl4 or you can take example of H2O. So which will be the central atom? This is most important. Out of these two, which will be central atom? Out of these two, which will be central atom? Out of these two, which will be central atom? So let me tell you which is single. Which is single? Suppose this boron is single because I have fluorine are 3, chlorine are 4 here. So this carbon is single, oxygen is single, hydrogen is 2. So that which is single, that will be always central atom. Okay, which is single, that will be always central atom. In this way you can determine the central atom. Draw the electron dot structure of central atom. Again BF3. This is very important, which I am telling you today. So please carefully just watch and draw. If I will take example of BF3, so you identified B is central atom, boron is central atom. Then after that you should know the electron dot structure that I told you. Electron dot structure only you can draw when you know electronic configuration. Why boron have 3 electron dot structure? Because boron atomic number is 5. When we are going to divide it according to Bohr's shell, so it will divide into 2 and 3. It will divide into 2 in K shell, 3 in L shell. So because of these 3, because 3 is in outermost shell, we are making 3 dot structure. Hope so you got. Okay, so boron is having 3 dot. So when boron have 3 dot, so we need to see if there is 3 dot, then number is also 3. It means that there is no lone pair. Very simple. Because all 3 fluorine is going to be joined with boron by sharing these 3 electron, like 1 electron, 2 electron, 3 electron. Okay, and on the other hand side, fluorine is there, 1 electron, fluorine is there, 1 electron, fluorine is there, 1 electron. There can be lone pair in fluorine, but lone pair should not be in this central atom. Okay, so it means that 3 shared and it becomes 3 to the 6. Although there is no 8, there is 6. This was the drawback of octet rule. So in this case, the shape of molecule is triagonal, simple triagonal planar, because 3 electrons are there in boron. All 3 is forming bond with fluorine by sharing electron. This is called second, draw the electron dot structure. Third, find the arrangement of electron pair. Find the arrangement of electron pair, mean bond pair or lone pair it is. Okay, then after that, determine the geometry based on bonding pair. So I told you all 5 steps. First step is formula, identify central atom in the formula. Second step, draw the electron dot structure of central metal. Third, find the arrangement of electron pair. These are the arrangement of electron pair, 1, 2, 3. 3 is the number. So 3 electron pair will donate the electron. Okay, so then find arrangement of bonding pair. It means that if it is arrangement of electron pair is single electron, like this way, and these are forming bond. And if lone pair is there, that also we need to see. After that, you can determine the geometry. Okay, this is for trigonal geometry. Why? Because 3 bond pair, 3 is the number. If there is a lone pair, then the geometry will change. So let's understand one by one whatever I explained you. Number of bond is equal to shape of molecule. Very simple. First, number of bond is equal to shape of molecule. Mean you should identify how many bond pair is there, so that will be the shape of molecule. Suppose here 2 pair is there, so 2 is linear, like this way. If 2 is there, first you learn this. 2 mean linear, 3 mean trigonal, 4 mean tetrahedral, tetra mean 4, hedral mean head, 5 mean trigonal pyramidal, 6 mean octahedral. So once, this is my appeal, try to understand, before going to understand the shape, you should understand the number. 2 mean linear, 3 mean trigonal, 4 mean tetrahedral, 4 mean trigonal, tetrahedral, 5 mean trigonal bipyramidal, 6 mean octahedral. Okay, so linear is this shape, you know very well. So these are the example. Trigonal is this shape. I am going to tell you, this table is already there, so I don't want to explain this table. I want to explain you the shape, in which first let me take example of this carbon dioxide. Carbon, as you know that there are 4 electrons in carbon, but you need to see in formula, with 1 carbon there are 2 oxygen. So it means that 1 oxygen will be this side, 1 oxygen will be this side. Now oxygen 1, 2, you need to make all the electron dot structure. That's why in this shape electron dot structure is the most important. So there are 6 electron. So in 6 electron, now see how we can make pair. Carbon have 4 electron, but 2 direction, 2 side oxygen is there only, not 4 side. That means that all the electron need to be bring 2 side. So what I will do, I will bring this electron here, I will bring this electron there. So like this way, the total electron that of carbon will become like this way, 1, 2 this side, 2 this side, 4, and oxygen 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. So in this way, 1, 2, 3, 4, 5, 6, 7, 8. You can see 8 electron become octet. 8 electron become octet. And this 8 become octet for carbon. So like this way, the shape of carbon become, if 2 is there, so shape of carbon become carbon double bond O, double bond O. This is linear shape. That's why carbon dioxide is linear in shape. Same way, when you come to know the electron dot structure or central electron dot structure of sulfur with oxygen, it will be sulfur dioxide. Now you can see formula is same, CO2 SO2, formula is almost same. But why then carbon dioxide is linear but SO2 is trigonal? Why? The reason is electron dot in central atom. Suppose in carbon dioxide, carbon is central atom, so there are 4 electron, whereas in sulfur there is 6 electron, so one lone pair is there. Because of lone pair, SO2 is trigonal in planar. Okay, so like this way you can practice all these. Now I am going to tell you the basic reason. The shape of molecule will change. Shape of molecule depend upon number of lone pair and number of bond pair. Number of bond pair and number of lone pair. Shape depend upon number of bond pair and number of lone pair. Again, when there is zero lone pair, 2 bond pair, the simple shape will be there, carbon dioxide. As you can see, in carbon there is no lone pair. Second, if there are total 3 bond मतलब 3 bond बनने हैं, in which 3 bond pair is there, 0 lone pair is there, then to simply trigonal पहला है. But when 2 bond pair and 3 lone pair, you can see 2 plus 1 is always 3. So 2 bond pair, 1 lone pair, the shape will be bent. 4 bond pair, 0 lone pair, shape is tetrahedral. 3 bond pair, 1 lone pair, shape is trigonal pyramid in case of NH3. Example is given here. So practice all this structure. Okay, today you will practice all this. 2 bond pair, 2 lone pair, bent shape as in case of H2O. 5 bond pair, 0 lone pair, trigonal pyramidal. 4 bond pair, 1 lone pair, seesaw. 3 bond pair, 2 lone pair, T shape. 2 bond pair, 3 lone pair, linear shape. So when you are going to see this table, dear students, you will know automatically what will be the shape, and shape will change according to the number of bond pair and lone pair. So this is very important to have knowledge about number of lone pair and bond pair, and as per the number of lone pair bond pair you can decide what shape is there. Okay, so today it's your homework. You will practice each and every structure that is given in this last 3. Number one this, number 2 and number 3. Okay, so all these 3 slides, from these 3 slides you will going to 4 slide, you are going to practice all these shape. Okay, so what we studied, dear student, shape of molecule depend upon the bond pair and lone pair. Shape of molecule depend upon its bond pair and lone pair. Shape of molecule contain bond pair as well as lone pair of electron. So we should have knowledge about bond pair and lone pair. Again, bond pair is what? Bond pair is simply the central metal that is sharing how many electron, and lone pair is what? Central atom, those electron, pair of electron which is not going to share. So one by one there are 4-5 shapes. First shape is its linear shape. Linear shape is going to be in this formula: beryllium hydride, magnesium chloride, calcium chloride. Okay, generally this linear shape is formed by group 2 member. Group 2 is alkaline earth metal with halogen. Central atom with 2 electron pair. There are 2 electron pair in valence shell of beryllium, like 1s2, 2s2. So we will take these 2. So 2 electron we are making 1, 2. Hydrogen also having 2 electron. So this will form this type of shape that is called linear shape. Next is trigonal planar in case of BF3, BCl3, AlCl3. Group number 13 with halogen. This type of shape or this type of molecule is made up by metal of group 13, element of group 13 with halogen, in which central atom having 3 electron pair. So that's why 3 electron pair is sharing 3 electron with fluorine and forming trigonal planar. Whereas bond angle also you need to learn, bond angle is 120. Okay, whereas here bond angle is 180, so their bond angle is 120. Third type of shape is tetrahedral. Tetra means 4, head means side. CH4, ClCl4, SiCl4. It means that member of group 14 with halogen. Carbon family with halogen will make tetrahedral shape, in which carbon have 2 electron in outermost shell, 4 electron in outermost shell. Suppose carbon is 6, so it means that 2 and 4 is outermost shell. Bond angle is 109.5 and the shape is tetrahedral. Next is V bent shape. V shape or bent shape will come when there is some lone pair. So 2 bond pair, 2 lone pair will make bent shape. Example we are taking as a water. So bond angle is distorted. It is 109.28 between bond pair, and 104 between 104 between bond pair and 109 between lone pair. Okay. Next is trigonal bipyramidal. It will come in PCl5 type. Group 15 to with group halogen, group 15 with group 17 when react, they will form trigonal bipyramidal. Okay, bond angle is 120 and 90. Two type of bond angle. One is this is 90, and you can see this is 120. Okay, these are 120. So this is trigonal bipyramidal. Why it is trigonal bipyramidal? As 5 chlorine need to adjust, so it will adjust like this way. Okay, here it has given. Next is lone pair and 4 bond pair. When this kind of molecule is coming, 1 lone pair, 4 bond pair, total is 5. So this is seesaw. As we know, in sulfur there are 6 electron in outermost shell. So out of 6, 4 electron is making bond pair with 4 fluorine, but 2 electron left. These 2 electron making lone pair. So 1 lone pair, 4 bond pair. So bond angle is 90 degree and 120 again. This type of shape is giving seesaw. Octahedral, when it is 6, octa means 6. So it is group 16 with halogen. So sulfur again, 6 electron is there in sulfur. The 6 fluorine are there, so there is no problem. When 6 sulfur, 6 electron, 6 fluorine, there is no lone pair, only bond pair is there. 90 degrees is the bond angle. You have to draw all these structure, okay, in your notebook. Square planar, that is 2 lone pair plus 4 bond pair, total is 6. As you know, 6 bond pair give octahedral. So 2 lone pair plus 4 bond pair will give square planar. Okay, square planar. As in case of xenon have 8 electron, in which 4 electron will make lone pair, 4 electron will make bond pair. So these 4 bond pair and lone pair will somewhere bring distortion and change the bond angle. So 90 is the bond angle. And these are the basic structure of this Vseprt theory, and it is given very nicely in your notebook or in your book as a table. So do practice and try to draw this diagram structure with the help of pencil. Send me your work in a PDF form, and you can ask me according to your convenience also. Okay, so limitations of Vseprt theories are what? It fails to predict the shape of isoelectronic species, same electron but different formula. And transition metal compound, we never found like copper, koi molecule ho copper ka, then iron, zinc. We found only alkaline earth metal with group P block elements. This model doesn't take relative size of substituent, unable to explain the atomic orbital overlapping. Okay, so this is all about for today's video. Although the video is little bit lengthy, but it must be compiled in one video. This was necessary to combine in one video just for relation. So tomorrow is Sunday. That's why I'm telling you, keep working on these digital classes, keep practicing this structure according to balanced shell electron pair repulsion theory. Okay, so hope so you enjoy this video. Thanks for watching this video. Till my next video, stay home, stay safe, and take care of yourself. Okay, so thank you, have a nice day. And one more thing, dear students, all the students are requested, those who are new, just make it sure. If you are not understanding, you can call me through conference. I'm ready there to help you. Okay, so thank you.